Okay, great. And this is all right, the recording?
Yes.
Yes.
Groovy, groovy. So a period is the smallest number p that causes the function to start to repeat its values. And a function is even if it has symmetry with respect to the y-axis. So for instance, our friend the parabola is even. And a function is odd if it has symmetry with respect to the origin. Different colors. Where's my blue? Oh, here it is. So our friend cube root is odd because every number on the first quadrant part maps to a number in the third quadrant. Here, for x squared, every number in the first quadrant maps to a number in the second quadrant. So if you fold along the y-axis, it'll match. For odd, if you fold twice along the y-axis and then again along the x-axis, it will match.
I
So
don't think the camera, at least I can't see if you're
it's not
Are you
moving.
are you writing something down? Because if you're
Oh
writing
my,
something down, we can't send it.
the camera's frozen, I'm pretty sure.
Yeah, probably.
yeah, it is. Oh my gosh. Okay, I'm gonna stop sharing and reshare.
Yeah, we can see it now.
Okay, yeah, we
Oh
can
my
see it
god.
now.
What a mess. Okay, so let's just really quickly. X squared is, or y equals x squared is an example of an even function because if we fold with respect to the y-axis, it matches, the graph matches. Cube root of x is an example of an odd function. And for odd, we say the symmetry is with respect to the origin. And that means twice folding. Folding first along the y-axis and then along the x-axis. And you can see that it does indeed match. So we're going to use those two terms, periodic and symmetry, or even and odd. We're going to go back and forth between saying something has even symmetry to saying it is symmetric with respect to the y-axis. With respect to is almost always gonna look like that, with respect to. So symmetry with respect to the y-axis is the same as even symmetry, and symmetry with respect to the origin is the same as odd symmetry. Well, let's just look at the symmetry because that's what we're just talking about. Let's look at our unit circle and think about sine, S-I-G, no, S-I-N. Okay, so we've got plus plus, minus plus, minus minus, plus minus. Which one does sine go with? S-I-N-E. First coordinate or second?
Second.
Second. So Notice that sine is the same in the second quadrant in both. I mean, in adjacent quadrants in both. Sine is positive in first and second. Sine is negative in third and fourth. And notice that the cosine is the opposite. And my brain just went, oh, yes, okay. So cosine squared will give us the same value for negative and positive. Sine squared will give us opposite values. And tangent and cotangent are always odd. For periods, sine and cosine repeat every 2 pi, but tangent and cotangent repeat every pi because they're positive in first and third and negative in second and fourth. So every pi unit, sine, tangent and cotangent come back to the same. Using right triangle definitions, which we've been talking about a lot, but here they are all in one place. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. And then we have our 3 reciprocals. Using a point on the unit circle, sine is y, cosine is x, tangent is y over x. Then we have our 3 reciprocals. Using a point T that is not on the unit circle, if T is a distance of r from the origin, then sine is y over r, cosine is x over r, tangent is y over x, and then the 3 reciprocals. Domain is all of the values that are allowed to be plugged in. Range is all of the outputs. So sine has a domain of all the real numbers. Any angle is going to have, and you can think of this as a unit circle. Any number on the unit circle has a y coordinate. Any number on the unit circle has an x coordinate. That always will happen. So that's why the domain of sine and cosine is all reals. Oh, the r with the double bar is reals. A z with the double bar, which we're going to see in just a sec, is all integers. And just to remember, integers are all of the counting numbers, all the negative counting numbers, and 0. And that symbol epsilon just means in. Groovy. So let's look at cosecant and secant. For cosecant, every single place that the sign is 0, cosecant will be undefined because cosecant is 1 over sine. Well, sine goes with y, and y is 0 on the x-axis. So we're not going up or down any at all. And the x-axis, let's see, we start at 0, and then pi, 2 pi, 3 pi, 4 pi. So every whole number of pi, we're on the y-axis. And that's why cosecant cannot be defined for any integer times pi. So 1 times pi, 0 times pi, 3 times pi, -2 times pi. All of those will give us a number on the unit, on the y, on the x-axis, and those numbers will have 0 for sine, and therefore cosecant will be undefined. Which other trig function can we think of as having sine in its denominator?
Cotangent.
Good, because let's go ahead and slap that up here. Cotangent can be thought of as cosine over sine. And having sine in the denominator means it also will have the same restrictions. So cotangent goes with cosecant for its restrictions. We know that secant will be undefined everywhere that cosine is 0. Well, cosine is 0 anytime we're at the y-axis. And the y-axis, let's see, it happens at pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2. Do you see that the number in front of the pi over 2 is always odd? And the way that we show that a number is odd, so I'm going to think of this as 2n plus 1 times pi over 2. This is how it's almost always shown, but this is how I think of it. 2n plus 1, plug in any integer. Plug in any integer at all. And what do you get? Tell me an integer.
5.
2 times 5 is
10.
plus 1.
11.
11.
Good. So every single 2n plus 1, if n is an integer, 2n plus 1 will be an odd number. So we can say that anytime the angle falls into an odd number times pi over 2, the secant will be undefined, and also the tangent will be undefined. Because tangent can be thought of as sine over cosine.
Just to let you know, you have 2 minutes.
Thank you. So let's just finish reviewing what we know. So we've got all of the reciprocal identities. Sine is the reciprocal of cosecant. Cosine is the reciprocal of secant. Tangent is the reciprocal of cotangent. We have the two quotient identities, that tangent is sine over cosine and cotangent is cosine over sine. We have the Pythagorean theorem, x squared plus y squared is c squared, or a squared plus b squared is c squared. But we also have the 3 Pythagorean identities. Tangent squared, sine squared plus cosine squared is 1. Tangent squared plus 1 is secant squared. 1 plus cotangent squared is cosecant squared. And we've got the 3 sine, SIGN relationships. Sine and cosine, cosecant are positive in first and second. Cosine and secant are positive in first and fourth. Tangent and cotangent are positive in first and third. And we'll pick up on Wednesday with example 1. And I'll correct the notes. Have a wonderful day.
You too.
Can I ask you 2 questions later
Of course you may.
after recording is done?
You want me to stop the
Actually,
recording?
Yeah.
Okay.
I also have a question.
You want me to stop the recording, Ben?
I don't really care if the recording's on or off.
Okay, I'm gonna go ahead and stop it.